Nerve signals travel to the end of an axon where they communicate their signal to another neuron or an effector cell like a muscle. This form of communication is called a synapse. Even though a nerve signal is an electrical current, it's not as simple as plugging in a toaster. In many cases, chemicals called neurotransmitters are released by the proximal axon and stimulate the effector's cell membrane. This version is called a chemical synapse. When the nerve signal arrives at the synaptic knob, voltage-gated calcium ion channels are stimulated to open. Calcium ions flowing down their concentration gradient diffuse into the synaptic knob. Synaptic vesicles in the synaptic knob contain a neurotransmitter. The calcium ions trigger exocytosis of these synaptic vesicles, releasing the neurotransmitter into the space between the neuron and its effector. This space is called the synaptic cleft. The membrane proximal to the cleft is called the presynaptic membrane, and the one distal is called the postsynaptic membrane. When the neurotransmitter diffuses across the cleft, it can stimulate the postsynaptic membrane in different ways. One way is that the neurotransmitter acts as a ligand that directly stimulates the opening of a ligand-gated ion channel. Another way is that it can trigger a receptor of a second messenger system that sets a series of events in action, eventually leading to the opening of ligand-gated channels. Each option results in a local potential in the postsynaptic membrane called a postsynaptic potential. This potential could either excite or inhibit the effector cell. Each are a normal result depending on where the nerve signal is coming from and where it's going to.